So in this video, I'm going to talk about the stereoisomer designations of alkenes, so E versus Z alkenes instead of cis versus trans. And so sometimes you're going to have a situation where you can't apply a cis or trans designation to an alkene, and if that's the case, we use E or Z alkenes to designate it. So if the alkene has two or more substituents, you have to use the Kohn-Ingold Prelog method for naming, which is just essentially E or Z. And so in order to do that, you first divide the alkene through the double bond into two ends. So essentially you're just separating it like that down the middle. And so now you have to find the first point of difference and designate a winner. And so you're just comparing these two substituents coming off of that carbon. And so you're comparing only this versus that. And so the first point of difference would be a bromine versus a chlorine. So it would be off of this carbon, so the C1 right there. And so now we have to designate a winner, and we're going to do that by assigning the one with the higher atomic number, the winner. So bromine has an atomic number of 35, while chlorine has an atomic number of 17. And so in this case, bromine is going to be the winner. So I'll just designate that by drawing a red star. And now that we've finished with the left side, let's do the right side now. And so we're comparing fluorine versus hydrogen. And so fluorine has an atomic number of 9, while hydrogen has an atomic number of 1. And so if that's the case, then fluorine has the higher atomic number, and it's the winner. So the bromine and the fluorine have the highest priority. And so essentially what we're going to do is now we're going to designate it as either a E or Z isomer. And so E isomers have the highest priority groups on opposite sides. So kind of think of it pretty similar to trans, while Z isomers have highest priority groups on the same side. Sorry for the typo. So Z isomers have highest priority groups on the same side. And so as you can see, bromine and fluorine are on the same side, with this plane being the middle. And so this would be a Z isomer. And so for E and Z designations, I think it's just really good to do a bunch of practice problems. So I'm going to do a couple more in this video and then some more in a future video. And so now let's try and designate this alkene below. And so what I've done is I've split it down the middle. And now we need to essentially determine which group has a higher priority. And so let's start with the left side. And so I've drawn in hydrogen just to make it kind of easier to see. So the first point of difference, you go to this carbon versus this carbon, it's the same atom. And then if you move another one away, you have a hydrogen versus a carbon. And so in this case, the carbon has a higher atomic number. And so therefore, this group down here would be the highest priority. On the right side, it's essentially the same kind of principle. So you go to this carbon here, and they're both carbon atoms. If you go to the next one, this group up here has a carbon atom, while the next one here, I didn't draw it in, but that would be a hydrogen. And so this group up here on the top would get the higher priority. So I'm just going to draw a star there. And so if the highest priority groups are on opposite sides, which is the situation here, so they're on opposite sides, you get the designation of an E isomer. So this molecule would be an E isomer or E alkene. And so in the next video, I'm going to do some more practice problems. Once again, I think the best way to get the hang of this is just by practice. And thank you for watching this video. If you found it useful or liked it, please be sure to give it a like and share it with your friends.